name is Jackie. Y'all can call me Jackie. In this particular video, I'm about to talk about 4 protocols, which is TFTP, HTTP, HTTPS, and FTP. Without wasting any more time, let me begin. First, I'm going to discuss about TFTP. TFTP stands for Trivial File Transfer Protocol. TFTP is a protocol that can be used to transfer files over networks and between computers. TFTP is a simple way to transfer files in comparison to FTP and SFTP. TFTP relies on UDP or User Datagram Protocol, as it is a connectionless protocol. Since TFTP uses UDP instead of TCP, it's an unreliable transfer protocol. Unlike FTP, TFTP is slower in its transferring process. This is due to the fact that the TFTP server needs to divide data to pieces when transferring it to the TFTP clients. TFTP have 5 message types, which are RQ, request to read a file, WRQ, request to write a file, data, contains a block of file data, ACK, used by peer to acknowledge each block of data, error, used by peer to indicate erroneous operations. So, how does the TFTP work then? In general way, a client establishes connection with the server, then requests for a file to the server. The server responds by sending the file back to the client, as simple as that. A TFTP server is always on call at port 69 for any incoming request from the TFTP client. Meaning, whenever a TFTP client requests to download a file, the TFTP client server will create a startup process. The TFTP client will send the command to the TFTP server through UDP. Let's observe the process with Wireshark. The data request consists of 2 requests, which is read request and the second one, write request. First, we need to capture those TFTP protocols. An easy way to do it is go to the Wireshark wiki and download the example capture file, like where I'm pointing here. I've already downloaded them, and let's start with the read request one. In the read request one, in the first line, you could see that my computer with this source, this IP, my laptop, is sending a read request to the TFTP server with this destination IP. After I send those read requests, the server will send back a data block back to me. After I receive those data block, I will reply with an acknowledgement or ACK to let the server know that they can send another data packet back to me. The process is equivalent to the stop and wait, meaning that the TFTP server waits until it receives an acknowledgement from the TFTP client before sending another chunk of data, and so on until all of the data have been sent. For the write request process in Wireshark, you could see in the first line here, my laptop requests a write request to the server in here. The client, then the server must reply with an acknowledgement first to know that I have established a connection. After I receive those acknowledgement, I can send another data block back to the server. After the server receive my data packet, they will send back to me an acknowledgement saying that I can send another data packet back to them. This will go on and on until all of the packet data I want to send is already sent to the server. And yeah, that's it. To ensure that your files are protected and sent correctly when using TFTP, you should only send files within your local area network. For example, if you want to send from your image to your firewall, you can use TFTP as it's within your local area network. However, keep in mind that the TFTP server will not provide you with security during your file transfer, and that's why it's crucial to only transfer files within your local area network. Next, I'll be discussing about HTTP. HTTP stands for Hypertext Transfer Protocol. HTTP is an application layer protocol that allows web-based applications to communicate and exchange data. Consider HTTP as the messenger of the web with TCP/IP based protocol. It is used to deliver contents, for example image, videos, audios. If 2 computers wanted to communicate or exchange data, the client or the one who requests the data and the server, the one who sends the data, must use HTTP to speak the HTTP protocol. 3 important things about HTTP. HTTP is connectionless, meaning that after making the request, the client disconnects from the server. When the response is ready, the connection is re-established to deliver the response, then it closes again. The second one, HTTP is stateless, meaning that the client and the server are aware of each other during current requests and forget about each other after the request is done. They will need to reconnect and provide information again if second connection is to be needed. The third one is HTTP can deliver any kind of data. As long as the 2 computers know how to handle it, HTTP can send it. Now you might have asked, how does HTTP works? First, you can see in the request response cycle that the client is on the left and the server is on the right. For example, if the user wants to go to a website, like say mywebsite.com, the user types in those links to browser Chrome, but first they need to be physically connected to the server. This is where internet comes to play. Using the TCP suite of protocols, it establishes the connection using the combination of cable media and wireless media. The client sends a request by HTTP message and disconnects with the server, waiting for a response. Then the server sends back a response, then disconnects too. This is the general concept of how HTTP messages work. Now, because HTTP is a protocol, it is defined by a set of rules. Let's take a closer look at them. This is the typical HTTP message. It will consist of a start line, a header, and a body. The typical HTTP message will be divided into two different kinds: a request message and a response message. In the request, you will see the structure in the start line consists of a method, an URI, and a HTTP version. In the headers are basically name values. There could be more than 3 values in these headers. The body does not exist because it is not needed. While in the response message, you could see HTTP version and status code in the start line. The same name value in the header, but within the body it consists of the file that we have requested. Let's make an example of bath message. This get one is the method, and this is the URI, and this is the HTTP version. In the header, you could see some example of value names such as host, accept, and accept language. As you can see, there is no body here because it is not needed. And the next, this is the HTTP method. There's plenty of it, and here's the description of it. Next one is the response one. This is the HTTP version, and this is the status code. With the header same as the request message, and the body consists of the file that is requested. And here's the example of all of the status codes. Let's try to observe those data through Wireshark. First, you got to go to Wireshark to start capturing first. After you started capturing, go to your web browser and type in any website you want that contains the HTTP protocol. I'll be using the very first website ever, and just wait for it until it is fully loaded. After it is fully loaded, go back to Wireshark and stop capturing, and then apply filter. The filter we're looking is HTTP. In the very first line, the second line here, you can see that my computer as the source is trying to get information from the destination, which is the IP address from the server. After that, the server reply with the status code OK, and then you could see that my computer requested to get this URI, and then the server replies with status code 200 OK. That is the general idea of how HTTP works. The next protocol I'll be discussing is about HTTPS. HTTPS stands for Hypertext Transfer Protocol Secure, and is the encrypted version of HTTP. It is used for secure communication across the internet or network. Here's a look of what will happen if you use HTTP. You could see that the data that are not encrypted in HTTP become unreadable in HTTPS. HTTPS communication is encrypted using Secure Socket Layers or SSL or Transport Layer Security or TLS. And how does it work exactly? Well, HTTPS uses a secure certificate from a third-party vendor. This is known as a SSL certificate. This certificate creates a secure and encrypted connection between the browser and the server. TLS helps encrypt HTTPS and can be used to secure email and other protocols. It uses cryptographic technique that ensure data has not been tampered with since it was sent. Things kick off with a TLS handshake. This is where the authentication takes place and session keys are created. Brand new session keys are generated when two devices communicate. The result is a deeper, more encrypted communication. Let's dive into the Wireshark capture. First thing is we need to start capturing. Saving. And just load in any website that you want. In this example, I will log into python.org. After it is finished loading, you could come back to your Wireshark and stop. And looks like I already have applied the filter TLS here. Well, as you can see, in this client hello is the very first thing that happens after the three-way handshake. That is seen, acknowledge, and my laptop sent a client hello, like over here, a client hello to the server. The server is supposed to send back the server hello certificate and server key exchange and server hello done, like this. And then I should send client exchange, client server spec and finish. Here we go. And then after that, the server should have said change cipher spec to finish. that's all about HTTPS. It's quite simple. It's just a more secure version from HTTP. The next protocol I'm about to discuss is FTP. FTP stands for File Transfer Protocol. It is a standard protocol to transfer files between computers and the server through a network. In a nutshell, FTP is the language that a computer uses to transfer files over TCP/IP network. FTP has two different data transfer modes, which is active and passive FTP. What is those modes exactly? Well, I'll cover passive mode first. In a nutshell, passive mode works by client-side sending through a random port with command channel to server port 21, asking what port and IP address they should be sending to. The server replies through the command channel the exact port they should be sending to, and then the client-side sends another random port in data channel to the server port and IP address that have been set up. After the connection has been established, data transfer could be done. With the active mode, in the other hand, the client side sends through a random port with command channel to server port 21. See that they are going to send that data through a specific port, and then the server replies by sending through from port 20 with data channel to the port specified by client side. After that, the connection is established, and then they can exchange data. Let's play around with the active FTP. First, I'm going to start capturing. With Wireshark. That I'm going to press Alright, after that is done, I should stop. Oops, I could stop this and then apply the filter TCP IP dot DDL equals CD. As you could see in these very first three lines of TCP, this is the three-way handshake to authenticate my laptop, and then the server asks for username in this line, and I reply it with sending the anonymous username. After that, it requests me to send a password, and then I also send the password in. After that, you could see that here the server has notified that I've logged in, and right over here is where this is where it differentiates from active and passive mode. This is where I request the server to change the port that I wanted, and then after this you could see that the port command is successful. After I know that the port command is successful, I requested an LST, which is receive a file from the server, and the server sends it through this whole line over here. After the transfer is complete, after the transfer is complete, I exited here, I quit, and then the server responds by saying 221 goodbye. This is where the protocol stops here after I quit it, and that's it with the FTP explanation. That's it with all the 4 protocols. I'm sorry if I've made any mistake. Thanks for watching.